Metal inert gas welding. So this is a very important type of arc welding technique, and it's one of the basic arc welding techniques that are used in the industry. And this lecture caters to the understanding of the basic concepts related to your metal inert gas welding technique. It is also called as MIG welding or gas metal arc welding. This is Dr. Gurraj Singh. So the talk is going to proceed with introduction, followed by the process, then the equipment details, and finally the advantages, disadvantages, and the applications of the MIG welding setup. So what is MIG welding first of all, and how is it different from the other welding techniques? Now in this image you can clearly see that it is MIG welding setup, that you have your electrode, which is here. This is connected to an external power source, and it is on the other side. The power source is connected to your workpiece, and the arc is struck between the electrode and the workpiece, and it is due to this arc that the actual melting takes place. Also, the very important point to note here is that the electrode is consumable. So you have a consumable electrode in case of MIG welding, and this is a wire electrode. It is not a solid electrode like in case of TIG welding. This is a wire spool that is continuously fed, and therefore it is a consumable electrode and also acts as the filler metal. So it also acts as the filler material. And you can see that there are two rollers that are used for feeding the wire, and the remaining setup, you have the nozzle here, and this nozzle is designed in such a way that it has the electrode wire moving through it from the middle portion, while the surroundings, so they are used for supplying the inert gases, which we have already studied previously, which can be argon or helium. So those inert gases, they form a protective gas umbrella here, and they prevent the weld pool from any sort of atmospheric contamination. So MIG welding, which is also known as gas metal arc welding, GMAW, it's a popular form of welding, and that's mostly used for welding low alloy steels and well suited for welding auto body parts and home repair projects. So from the type of material that it is commonly used for and for its applications that has been mentioned here, it is very easily noticeable here that this type of welding is probably a cheap version of welding, and it's used in day-to-day life. It's a very commonly used welding technique. And it is an arc welding process that joins metals together by heating them with an electric arc and formed between a wire electrode and the workpiece. So MIG welding technique is again a type of arc welding technique. The wire electrode is fed through a MIG gun. So this is the MIG gun nozzle. This is the tip of that MIG gun that you see here. We'll see the gun in the coming slides. So this is the tip of that MIG gun that is used to supply the wire. And the shielding gas is also released through the MIG gun to protect the arc and the weld puddle from being contaminated by the atmosphere. So these are the important things worth noticing in case of your MIG welding setup. Now here again, you have a more detailed block diagram of the setup here. So you have, first of all, the supply of gas. On to the left, this is the inert gas that is being supplied. So you can see the connections. They are joined directly to the MIG gun. Secondly, through the center of the MIG gun moves your wire. And this wire is driven using this wire drive, the two rollers that we saw in the previous slide. And this wire is rolled over a wire reel or a spool, and it is continuously fed. Also, there's an external power source. So from that external power source, you're connecting the power source to the workpiece, and the other terminal of the power source is connected to the electrode. Now this can be either this way, that your workpiece is connected to the positive terminal and the electrode is connected to the negative terminal, or vice versa, but this is called as the concept of polarity. And in case of MIG welding, you will always connect your electrode to the positive terminal. And why is that so? Because the electrode is consumable, and connecting it to the positive terminal will make that consumption easier, because it is the anode always which bears the higher temperature, because the electrons are colliding at the anode and they are moving through the cathode. So as a result of that, it is always advisable to connect the electrode to the positive terminal in case of MIG welding, and this is also referred to as a polarity which is called as DCEP, direct current electrode positive, since the electrode is connected to the positive terminal, and this is also called as reverse polarity. So these polarities, the concept of polarity we'll be seeing separately in another individual video, but for now it is very important to note that MIG welding is always preferably done using reverse polarity or direct current electrode positive polarity. Then there are certain controls for governing the wire feed. So these are basically the electronic controls for operating the system. So the consumable bare electrode is similar to that of the parent metal. So another important point to note here is that mostly the electrode is of the same material as the parent metal. The arc heats and melts both the workpiece edges and the electrode wire, and it is now that the fused electrode material is supplied to the surfaces of the workpiece. So it is this electrode that melts and is supplied to the workpiece edges. It fills those edges and eventually forms the joint. So the only thing that the operator here does is he controls the arc positioning as well as the speed of the arc. Now again, you can see here on to the left at the bottom, this is how the MIG welding technique takes place. So you have a wire fed electrode and you have the workpiece, and you start moving the electrode along the joint to be welded, and it gets melted and fills that gap. So the concept underlying MIG welding is simple. The arc being struck between the tip of the reel fed wire as it emerges from the torch and the workpiece. So it is these two components between whom the arc is being struck. Then the shielding gas, it prevents oxidation forming. And with most MIG welding sets, the user sets the wire feed speed, which determines the current, and then the user sets the voltage to suit that current. So it is very important to know about the process parameters. And now those process parameters, they can be the voltage, the current, and the speed with which you are moving your torch. So these are three of the most important parameters that will influence the properties of your final weld. If you're increasing the voltage to a certain level, and then in the next step, if you're decreasing it beyond a certain level, your results are bound to vary. And that is where the parametric optimization comes into play. So now we'll turn towards the equipment that are used for the MIG welding setup. So you can see that this is a commonly used MIG welding setup. So this is a compact setup. You have everything here. You have the wire spools somewhere inside. You have the controls here. Then you have the torch, and then you might use an external source to supply the inert gas. And this is how the gun looks from the front. So you can see that this section is used for supplying the inert gases, while the wire is coming from the middle. So this is how it is set up. And what are the four most common parts or components of a MIG welding equipment setup? First of all, the most important is the power source, because without power, without current, without voltage, you cannot operate any arc welding setup. It will not be possible to strike the arc. Then there's a wire feed system. So this is a wire feed system again that is used for feeding the wire. The conduit or the connections, these wires that are used for connectivity, and finally the gun, the MIG gun. So the MIG gun, if you just have a look at it from a very closer perspective, so you'll see that it has many important internal points, and there are certain points that make it different from a TIG gun that we'll see in the video when we discuss TIG welding. So this is how the MIG gun usually looks like. So it has a braided copper power cable inside, then a power cable insulation, it is applied around the power cable. Then the most important thing is the trigger. It is the trigger that you pull, and then your wire starts being fed. And then there's a housing that is applied around that so that you can actually hold it from this. And you have this conductor tube, and finally a nozzle at the tip of that tube. And it is this nozzle through which the wire is going to be fed. Now, what are the advantages of MIG welding? Specifically when you compare it to other welding techniques like TIG welding or shielded metal arc welding. So it has higher welding speeds, it has better deposition rates, less post-welding cleaning is required, then better weld pool visibility is there, and then no stubborn losses or wasted man hours caused by changing the electrodes, because there is no need to change the electrodes. Your wire is a continuously fed electrode and it lasts for quite long. And then low skill is required, so you do not need much skilled workers in this case. Positional welding offers no problems when compared to other processes. The process is easily automated, no flux is required, and ultra low hydrogen process. So these are some of the advantages of the MIG welding process. Likewise, turning over to the disadvantages side, but initially the cost is going to be a bit higher because it's a better setup as compared to the shielded metal arc welding process. Then the atmosphere surrounding the workpiece has to be stable, and therefore the process is limited to drought-free conditions. Then the maintenance costs are higher. Then setting plant variables requires a high skill level. So for setting plant, you need better skills, not for the operation, but for the setup, and less efficient where high duty cycle requirements are necessary, and radiation effects are more severe. So radiation can play a severe effect in this case. And lastly, if I turn over to the application side, it has a whole variety of applications and areas where it can be used. So it is most commonly used in heavy duty arc welding projects, and it is standard for pipe welds, such as the water you rely on for drinking, cooking, sanitation comes through pipes that would not be possibly welded without MIG welding. Then it is also used in a technique that is called as hard facing. Then for the rail tracks also it is used. And auto industry completely relies on MIG welding because it is a very handy technique. The setup can be carried away wherever necessary. So these are some of the applications that have been mentioned, but usually it can be used in a very, very wide range of areas and applications. So this was just a theoretical introduction about MIG welding. Similarly, in the next video, we will be looking at a theoretical introduction about TIG welding. And after that, we will have a full dedicated video to the study of the parameters that are involved here, the mathematics involved here, and also a video about the polarity and its concepts. So I would like to end this video here. Thank you.